Welcome, everyone. Good evening. Welcome to the CSH monthly seminar. Welcome, everyone offline and online. We're very delighted today for this session. It's been a while. We've been preparing this with Jean-Baptiste Fressoz and Ashwini Swain here. Today's talk is entitled In Tech We Trust, a History of Technophilia in the Climate Mitigation Expertise. We're delighted to host Jean-Baptiste Fressoz, historian of science, technology, and the environment, and research fellow at the French National Center for Scientific Research, CNRS, affiliated with the Centre de Recherche Historique at the School for Advanced Studies in Social Sciences in Paris. Jean-Baptiste Fressoz's work examines how industrial modernity, ecological transformations, and forms of state reasoning have shaped what societies consider realistic or inevitable in environmental policy. This evening, he will trace the technocentric tilt in climate mitigation expertise, especially in the work of the Intergovernmental Panel on Climate Change, the so-called IPCC, and more specifically, its Working Group III, which focuses on mitigation and show how certain cost-effective technological pathways came to dominate, culminating in the prominence of carbon capture and storage, called CCS, as well as bioenergy with carbon capture and storage in net zero scenarios. It sounds a little fuzzy or complicated, but as you will see in his presentation, it's very clear and enlightening. The talk will be followed, and we thank him again for the idea and for accepting this, by a discussion with Dr. Ashwini K. Swain, formerly fellow at the Sustainable Futures Collaborative and regulatory assistant project member right now. Also an associate researcher at CSH, whose work focuses on energy policy and governance and the politics of energy transition, especially the political economy of electricity and the challenges of a just transition away from fossil dependence. Ashwini also teaches at the Tata Institute of Social Sciences, TISS Hyderabad, bringing a perspective that connects research institutions and real-world policy constraints. Jean-Baptiste, Ashwini, thank you, both of you, for accepting this seminar and conversation today. Just a quick reminder for everyone, you know the drill. Online, please do not turn your mic on unless later on there's someone with a mic on. Sajal, please, can you turn your mic off? Everyone online, just try to remember this. And later on, when you have questions, you can just drop them in the dialog box and we'll refer to them once we open the floor. Jean-Baptiste, thank you again for being with us. The floor is now yours. We'll let you start your presentation and check everything works fine.
Okay, hello everyone. Thanks a lot for having me at the CSH, and thanks Ashwini for once again actually having me on one of your seminar you organized. I'm going to talk about a paper which was published in Energy Research and Social Sciences last September. It's a paper which created a little bit of stir, but for no reason. I mean, basically, what I say is completely obvious and straightforward for anyone involved in these issues. And actually, part of the paper emerged from ongoing discussions with experts from within IPCC Group III, and emerged from also discussion with colleagues of mine who are actually better experts on the topic than I am. I'm mentioning Béatrice Cointe, who is a sociologist at the Centre de Sociologie d'Innovation. I could also mention Christophe Cassin at the CIRED, who has been following integrated assessment modeling for over a decade now. And I'm also thinking about Luz Sturenberg, who wrote an MSc dissertation under my supervision on negative emissions. And I will come back to what negative emissions are. That said, I'm going to talk about this paper. To start the discussion, I think it's good to remember 10 years ago when the IPCC, when the COP in Paris took place. I was struck at the beginning, right when the Paris Agreement was signed, by the enormous ambition of... You want me to make full screen, right?
He's still. Jean-Baptiste, sorry, I was just agitating myself to try to ask you that only that you just did. Thank you so much for that.
Is it okay?
Perfect. Wow.
Okay, so 10 years ago, COP in Paris, Paris Agreement. I mean, the goal of the 2 degrees Celsius seemed to me extraordinarily ambitious. As an historian of energy, I thought it was quite unrealistic to imagine a global decarbonization of the economy in half a century at most. Um, and then there was the 1.5 degree target. So, I mean, the Paris Agreement was 2 degree maximum, and if possible, 1.5 degree. And then there was a report written by the IPCC saying that 1.5 degree was possible. And I really thought it was something wrong. There was something fishy about this report and also fishy about the Paris Agreement. And what was the expertise behind all these wonderful targets? It is indeed the IPCC Group III report, and especially integrated assessment modeling, which study the way we can reach globally carbon neutrality by 2050 for the 2 degree, for the 1.5 degree target, and 2070 for the 2 degree target. Global, I mean, we're talking about global CO2 emissions. And I started to be interested in these reports at that time, after the 1.5 degree report published in 2018. And I realized that they were extraordinarily technophile in the sense that they were really focused on technologies, and very little was said about what we call no sufficiency or demand management or reduction of demand, reduction of consumption. This, I mean, it was not absent, of course. I mean, it was mentioned, but it remained quite marginal or secondary. If you look at all the 6 reports published by IPCC Group III since 92, and you look at them quantitatively, what are they talking about? And you just look at numbers. It's a very limited way to understand the problem, but it's one way. And then I will go back to more qualitative understanding of these reports. They mainly talk about technologies. I mean, most of the discussion is about new ways of producing energy, and everything is, I mean, most of the discussion is about high tech. For example, in the 2007 report, they talk about nuclear fusion as commercially available before 2050. In the last report, in the 2022 report, they talk about the Hyperloop, Elon Musk's Hyperloop, super high-speed train running in vacuum tubes that is described as an emerging technology. So, I mean, it seems just anecdotal, but actually, when you look at if you read the report, I think it's quite easy to be convinced that there is something wrong about the understanding of the importance of innovation. If you look at just numbers, once again, you see that technology is present over 2,000 times in a 200 pages report, and innovation is present almost 2,000 times in a 2,000 pages report, hydrogen 1,000 times, carbon capture and storage, on which I will come back over 1,000 times, but degrowth is virtually absent. It's mainly present in footnotes. And probably even more significant, prohibition, I mean, bans, is almost absent. There are very few occurrences of the word prohibition. Most of the time, it is a reminder to explain how prohibition are very unpopular. And sufficiency, which is now the code name to describe demand management, has really gained importance only in the last report, in the 2022 report. And even if it starts to receive some interest, it is still secondary. I mean, there are over 200 occurrences against 1,000 for hydrogen, for instance. And actually, if you look at the introduction of the last report, they acknowledge that it is the first time that sufficiency has been highlighted as an aspect of climate mitigation, showing that before the 2022 report, even if there were like scattered references to sufficiency, it was sufficiently invisible that I would say decision makers or people receiving the report did not really understand that sufficiency might be part of climate objective. beyond the numbers, there is also the vocabulary, which is interesting. The terms which are used. Innovation is very often linked with very positive words. It's about green innovation, low carbon innovation, mission-oriented innovation, just innovation. I mean, responsible innovation. Innovation is good. That's really one of the big assumption which is made by the IPCC. And that's why, like fashionable innovations, innovation that were discussed in the press just before the report, are also featured in a far too important way. For instance, blockchain, which is now forgotten but is still existing, which is mainly used for financial speculation, is presented as with very interesting applications for climate. Like it could promote car sharing, electric car charging, and cycling. Or it could increase transparency mechanisms for green financial instrument investor. In the last report, everything is becoming smart. Smart cities, smart grids, smart mobility, smart agriculture, smart urban planning, smart logistics, smart manufacturing, smart materials. Most of these words, they come directly from industrial promotion. For instance, smart cities, it has been shown, came from Cisco and Microsoft, who started to try to sell IT services to municipalities in the US and started to talk about a smart city, but it was just like promotional literature. In the same way, in the last report, there is a mention of the fourth industrial revolution. As an historian, we are not very clear what were the first, the second, and the third industrial revolution. But the fourth industrial revolution, we are told, is compatible with sustainable development goals, because this fourth industrial revolution will reduce demand for materials and energy. And you got this kind of, discourse, new business models based on the circular economy foster sustainable economic growth, as well as global competitiveness and innovation and potential synergies with Industry 4.0. There is a lot of this rubbish in the report, which is, I think, very significant, extremely problematic, and could discredit actually some interesting elements which you can read in this report. But I mean, at first glance, there is a very strong porosity, a transfer of industrial discourse, commercial discourse into climate expertise. What is striking in this report, it is that very often there are internal contradictions in these pages, and it is normal. We are talking about a 2,000 pages report, which is written by hundreds of different scientists. It's quite natural that you find contradiction. An interesting one is about hydrogen. Hydrogen is extremely important for net zero scenarios because it is necessary to decarbonize what is called hard to abate sectors. We are talking about steel manufacturing or aviation. And what is striking is that on the one hand, you've got two inlets in the report explaining that hydrogen as an energy vector carries with it like very, very deep difficulties. There is also an inlet which is very critical of this notion of hydrogen economy, which is, of course, a slogan. It has no serious grounding. And nevertheless, in the report, you've got this fantastic depiction of a future where hydrogen will play a very important role. I mean, it's a nice description of the technological imaginary of the IPCC Group III. You see that you will have hydrogen airplanes, and hydrogen airplanes I mean, it is said that it will be good for climate and it will be efficient, which is certainly not the case. And they also talk about direct air capture, which is a very dubious technology, which would allow you to filter air, take the CO2 molecules which are mixed in the air, and put it under the ground. So there is a lot of internal contradiction in these reports, which mean that it is quite difficult to have like one simple summary of what they say about the technology. Most of the time, they say it is very important, but at the same time, it is very costly. I think the beginning of the problem of all this discussion around technology and climate, it is that it is based on a very important confusion between technological dynamics and material and energy dynamics. This is also a graph which is taken from the last IPCC report. Um, it is in the chapter, the general chapter about energy transition. And all throughout this chapter, there is this confusion between technological change, uh, technological substitution, and energy transition. And in this chapter, it is clear that for the people who wrote this report, the energy transition is a diffusion of technology, a diffusion of innovation, which will replace old technologies. So the transition is summarized by this beautiful X curve, where you've got a new technology replacing clean technology, replacing an old and brown technology. This is a very serious intellectual confusion. I will explain you why just a minute later. This graph is taken from a group of researchers called the transition studies. The transition studies, they emerged in the 1990s. Basically, they really thrived on this confusion between technological dynamics and energy dynamics. They recycled very classic understanding of technological innovation as a creative destruction, as a Schumpeterian creative destruction, as a replacement of the old, and they recycled that to talk about energy transition and climate change. It mainly emerged in the Netherlands, but then got a global reach. It is extremely influential. It is so influential that you can find the trace of its influence in the last IPCC Group III report. And the comment on this graph in the IPCC report is interesting because it is the only place where history is mentioned. And they say energy transitions can occur faster than in the past, or a low carbon energy transition needs to occur faster than previous transitions. As you know, this is a very strange idea because for the moment, energy transitions at a global level, the one which matters for the climate, uh, for the moment has not really started. We are hoping to pass peak coal now. It really depends on basically the GDP growth of China and India. But I mean, there is no example of a primary energy which has disappeared. So we really can't refer to any historical example of having succeeded to do an energy transition in the past. What we really need to understand is that the old has not disappeared when the new energies appeared. And that's why, for instance, wood energy today is increasing. And wood energy today is the double as nuclear energy. So we are living with all sources of energy. I mean, it's not just this 2022 report, which has this very wrong history. This is a quote from the 2018 report, the special report on 1.5 degree. And they say that 1.5 degree requires very important transitions, which I quote, are unprecedented in terms of scale, but not necessarily in terms of speed, right? So they try to infer something from the past, saying that what we have to do is not unprecedented. And I think this is deeply wrong. What we have to do is completely unprecedented. It is absolutely mind-blowing for any historian interested in history of energy, history of technology, history of materials. This is really science fiction seen from an historian perspective. Why? Well, simply because, as I just told you, energies in history have tended to stack up on each other. There is a cumulative dimension in history of energy. And it is even worse than that. It is not just energies, it is all raw materials which have expanded. When we talk lightly about innovation to resolve the climate crisis or any environmental problem, we have to remember that despite all the innovation that we had during the 20th century, all raw materials have increased. There are very few examples of raw materials whose consumption, global consumption, have decreased. One good example is asbestos, because it is a toxic material, it has decreased, but it's because there is a prohibition, precisely the term that the IPCC doesn't want to use, but prohibition works. I mean, that has decreased world consumption of asbestos. But there is really a fundamental difference between the history of materials and the history of technology. I think it's really a very basic point, but we have to keep that in mind. And it's probably the important message that history can provide to the current crisis. The history of technologies, you've got kind of obsolescence of technologies, you've got replacement. Very often it is later than we believe, and it's much more difficult than we believe. But this is not the case for materials. Raw materials are never obsolete, and primary energies have never been made obsolete for the moment. This problem came really from the fact that we confuse dynamics of technologies and dynamics of energies and materials really comes from the 1970s. It is at that time that the idea of energy transition became popular. Before the 1970s, there were only a very small group of scientists who talk about energy transition. These were the atomic energy scientists. And they would imagine a transition, but in a very, very long time when fossil fuels would be exhausted or too expensive to be extracted. But then during the energy crisis caused by the oil shocks of the 1970s, this idea of energy transition became commonplace. At that time, energy transition meant anything that would increase energy sovereignty. It was used by Jimmy Carter in 1977 in a famous speech, important speech, that really promoted this word, energy transition. But at that time, Jimmy Carter meant coal, basically, or of course solar as well. But coal was very important for the energy transition at the time. Another very important element is that energy transition really is the hair of the 1970s, of the energy crisis, and is also linked to a new vision of energy dynamics, where you consider energy dynamics in shares. So it is the share of wood, the share of coal, the share of oil, and the changing share of the energy mix, which is an energy transition. Jimmy Carter talked about energy transition in 1977, and he talked about history, saying that in the past, the US had done two energy transitions, one from fuel to coal, the second from coal to oil. And he commented on this graph. And it is really a very innovative graph where you put everything in shares, the share of wood, the share of coal, the share of oil. And when you do that, of course, you can make appear beautiful transitions. It is very original because at that time, most of the representation of energy dynamics had this shape. So it's a very, very different understanding of the dynamics at play if you look at this graph or if you look at this graph, obviously. This graph was stolen or taken from a work which has been very, very influential in all the talk about energy transition. It's a graph made by Cesare Malchetti, an Italian atomic scientist who really started to look at global energy mix in shares. And he described this tendency of replacement, like you had waves of energies, the wave of wood, the wave of coal, the wave of oil. But it was very innovative and it was created for specific purposes. But the important thing is that Cesare Malchetti was working at IASA, and IASA is a key scientific institute, research institute near Vienna in Austria for the IPCC, for the creation of the IPCC, and especially for IPCC Group III. And at IASA, they were very influenced by two sorts of research. The first one, they were instrumental for two kinds of researches. The first one is using computers to model the future and the energy futures. And it is at IASA that they start to create what we call now integrated assessment modeling in the mid-1970s. And they also study technological diffusion understood as a solution to our energy predicaments. We have to remember that when the IASA was created in 1972, the book that truly shocked everyone was the Club of Rome report, the Limits to Growth report of 1972. And the energy group at IASA really thought their aim and their mission was to refute this report or show that you could use the same kind of methods like the modeling of energy system to show that you had smooth transition paths out of fossil fuels in 50 years. So in IASA, you had both computer modeling, which would then gave birth to the net zero scenarios of the IPCC, and you also had these transition studies emerging, and basically the idea was that the new paradigm is Schumpeterian, and they apply this substitution model even on economic theories, saying that Keynesian has been replaced by Schumpeter. One of the key characters at IASA was William Nordhaus. William Nordhaus has received the Economic Nobel Prize in 2018 for his work on climate change. And he's also the one who introduced the idea of backstop technology. Backstop technology is a very important assumption in climate economics. It is the assumption that you have a clean tech, something which is a substitute for brown tech or CO2 emitting technologies, if you accept to pay a certain price. It's a very important hypothesis, and it is commonly used today in climate economics. The recent Nobel Prize, Philippe Aghion, also used this idea of clean technology, but in fact, it's the backstop technology, it's the same thing. And backstop technology emerged during the energy crisis of the 70s. At the beginning, it is an invention of William Nordhaus, who wanted to reflect on the exhaustion of oil and fossil fuels. And it is introduced in a 1973 paper where William Nordhaus explained that the end of fossil fuels is not an existential threat for the US economy because we should not underestimate the power of innovation. And at that time, innovation was the breeder reactor, a special kind of nuclear reactor, and hydrogen. And I mean, why we are all talking about energy transition and why the IPCC is talking about energy transition, it's because we have recycled a vision of the problem of energy system, which emerged during the energy crisis and has been recycled for the climate crisis. In the case of William Nordhaus is very clear. In 1973, he talks about backstop technology and energy transition in the context of the energy crisis. Basically, oil is becoming more expensive. Does it mean that we have to tighten our seatbelts and consume less oil? On the contrary, we have to extract oil now while it is expensive. And 2 years later, he writes the very first article by an economist on climate change, and he says exactly the same thing. There is a greenhouse effect. Does it mean that we have to limit our consumption of fossil fuels? No, because it will be much easier to do the transition later when we'll have the backstop technology, which was at that time the breeder reactor. I will skip that. It is in this context, intellectual context, that the IPCC was created. And William Nordhaus thought was really influential in the first two reports of the IPCC Group III. I mean, the IPCC, we have to understand it the creation of the IPCC, we have to understand it in the context of the mid-1980s. In the mid-1980s, the World Meteorological Organization and the UNEP had already created a group of experts called the Advisory Group on Greenhouse Gases. And the Advisory Group on Greenhouse Gases was very clear on the magnitude of the problem, that there was global warming. We had to act immediately and decisively. There was no need for further research in a way. We knew, basically, they explained that they knew enough to recommend to the government to act now. And now meant that in 1988, at the Toronto Conference on Climate Change, the final declaration of the Toronto Conference stated very ambitious objectives. They said that they wanted to cut CO2 emissions by a quarter before 2005. And to do that, they proposed to implement a tax on fossil fuels in the rich world that would finance development and adaptation in the poor world. it is at this very same year, there was a heat wave in the US with a drought. And it is also during this summer of 1988 that Jim Hansen made his famous speech at the Senate saying that climate change has begun. So there was really a context pushing for action. The US government, when they heard about the conclusion of the advisory group on greenhouse gases, fell off their chair. I mean, they could not accept the idea of reducing by a quarter CO2 emissions by 2005 because it would have very important consequences on their own energy policies. And that's why they wanted to create a new group of experts. And this group of experts would be the IPCC. Of course, the important letter in IPCC is the I. It means intergovernmental and not international. The key objective was to put governance back into the loop of climate expertise, of climate research. And it was clear that for the US government, the IPCC had to be organized so as to meet US government objectives, as you can read in the Department of State archives. And the key thing is that you had to ask governments to nominate for experts, and these experts should reflect the whole range of government policies, not only environmental policies, not only research policies. They had to reflect on industrial policies, agricultural policies, right? So really the point was to put in the expertise and the production of expertise, serious people with an understanding of the economic constraints linked to the reduction of CO2 emissions. I mean, it was quite clear at that time in the US that climate change will happen. That the idea of getting out of fossil fuels to stop climate change was ludicrous. In 1983, there is a very important report by the National Academy of Science entitled Changing Climate. I mean, the title in itself is significant. The climate is going to change. It is changing, right? And the last chapter of this report was written by a future Nobel Prize in economics called Thomas Schelling. And he said basically where is carbon underground? There is a lot of carbon in the US, in USSR, and in China. So you got two global competitors plus a future economic giant. They are bound to extract all this carbon. So he was a specialist of game theory, and for him, climate change was just an example of game theory. Climate change will happen. It was just the real politics that would explain that climate change will happen. So basically, what were the objectives of the IPCC for the government, of the US government? Well, it was not protecting climate. It was protecting the economy from the side effect of all this climate discussion, right? And in the archives of the Department of State, it is clear that the emphasis has to be put on technology, on innovation. The key thing is to organize technological transfer for the poor countries to have access to more efficient technologies that were developed in the US. And it was also to ensure the transfer of technologies that will be useful for adaptation, especially everything related to coastal management and the rise of water. It's also, I mean, another interesting archival source is the discussion that took place right before the Rio conference in '92. So the big conference that organized the UNFCCC. Robert Weinstein was the head of Group III, and he was also the chief negotiator for the US in Rio. And he described this conversation with John Sununu, who was his boss, the chief of staff of George Bush at the time. And it was clear that his orders were, first, do not commit to emission targets. Second, do not pay for damages. Do not commit any payment for climate damages if there are. And third, play the technology card. So play the technology card was really, I mean, an obvious choice for the US negotiators at Rio in 92. It made perfect sense from a US point of view to play the technology card. It was at that time the biggest emitter, the biggest technological power, so it made sense to talk about innovative solutions for climate change. The rise of all this technological discussion is also very easily understood when you go back to the intellectual atmosphere of the 1990s, especially after the collapse of the Soviet Union. We have to remember that at that time, what was really the key topic was sustainable development. And sustainable development at the time, what it meant integrating multinationals into the production of environmental expertise and environmental regulation. The key thing was that multinationals were responsible for many environmental problems, obviously, but they were the one who could solve these environmental problems. They had the money, they had the know-how, they had the R&D department to find solutions. And it was really pushed by Maurice Strong, who was the General Secretary for the Rio Conference in 92, was also, by the way, Canadian oil man. But it was not just Maurice Strong. It is really Kofi Annan also pushed the UN Global Compact, which is really a kind of deal with multinationals and the UNO to promote responsible globalization. And it had also an environmental dimension. You have then the oil company, which participates to different compacts, different industrial organization to promote sustainable development. So it is no, how would I say, it's no coincidence that you have so many employees of oil companies, electrical producers, or automobile companies inside the IPCC Group III report. And it's no coincidence that you have had very important figure linked with fossil fuel interest, head of the IPCC. Rajchandra Pachauri is a good example. He was from the Tata, close to Tata, and also he was at the board of important electricity corporation in India. And more recently, Ho Seung-lee, who was the previous chair of the IPCC, was at the board of Hyundai, a huge conglomerate active in many different fossil fuel and steel, and of course, automobile companies in Asia, in South Korea. At the beginning, I thought that this was not that important, that all these employees of fossil fuel companies had not really influenced the content of the report. But in fact, it has played a key role for one specific technology that I have studied. Not for all the other, I don't know for the other, but for this case, it is quite clear that I can show that they have had quite an important influence. It is all the technologies revolving around carbon capture and storage. So what is carbon capture and storage? The idea is if you've got a gas power plant, a coal power plant, or a cement factory, or a steel factory, instead of trying to decarbonize the process, which can be very difficult, you can capture the CO2 outside the chimneys, just out of the chimneys, liquefy the CO2, and send it under the ground. For a long period of time, this solution was thought as ludicrous by most of the experts, even by the expert of the IPCC, by the way. In the 2001 report, the IPCC states that producing electricity with CCS makes electricity production from coal more expensive than nuclear electricity. So there is no point in promoting CCS. It's not a serious technological solution. And it all changed with this report from 2005. It's a special report by the IPCC Group III on CCS. And it really changed the discourse around CCS. Suddenly CCS shifted from a kind of sulfurous technology with very dubious scientific background to an important potential green innovation. When you look at the references of this report, you see that a lot of references came from a series of conferences called Greenhouse Gas Control Technology Conference. And these conferences were financed by the various fossil fuel companies. They were also fostered by the US, Norwegian, and Canadian government at the beginning. There was a small think tank set up with various oil majors and the International Energy Agency in Paris, which was specialized on greenhouse gas carbon capture and storage. So it is really at this intersection of international organizations, but perhaps I don't know why, but they decided to externalize this expertise at the intersection of the International Energy Agency, the IPCC, and fossil fuel companies, that this idea of capturing carbon started to gain credit. And this is an example of the kind of graphic that you can find in the 2005 report, which I think is quite extraordinary. They proposed to liquefy CO2, but then what do you do with all this liquefied CO2? Well, you just dumped it under the sea, on the floor of the oceans, because there is so much pressure at 6,000 meters depth that the liquefied CO2 remains liquefied. Anyway, so you really have a very specific kind of imaginary that comes from the oil industry, obviously. And then after this 2005 report, the number of publications on CCS skyrocketed. It's really a turning point. And actually, there is even a journal created in 2007 on CCS, specialized on CCS, a peer-reviewed journal. And they acknowledge that it's really the IPCC Group III report of 2005 that really changed the interest in the topic. Another key element is probably the integration of CCS in all the carbon credit system, which could make financially interesting the idea of capturing CO2. And that created an incentive to set up startups. I think in a very kind of problematic way, authors of these reports created a report from the IPCC on carbon capture and storage created companies that became extremely valuable after the decision of including carbon capture and storage in the clean development mechanism of the UNFCCC. And then after the CCS was just the first step. The second step was to couple CCS with bioenergy to create negative emissions. The idea emerged at the beginning of the 2000, the decade of the 2000. A chemist working from a paper manufacturer in Sweden realized that if you put a CCS device on the effluent of a paper factory, you create negative emissions because the paper industry used a lot of biomass to create energy. The wood residues are used to power all the factories, all the processes used for paper making. And paper making is a big industrial consumer of energy. It's the fourth industrial consumer of energy. So we are talking about significant amount of potential negative emissions. The idea was taken up by influential people inside YASA, by younger modelers, people working on computers to imagine how you can minimize the cost of getting close to zero emissions. And they pushed this idea of bioenergy with carbon capture and storage. This is a picture from the 2014 IPCC Group III report. I mean, as you can see, electricity in the scenario is becoming the biggest carbon sink, actually. in the average range of the scenario, BECCS, so you produce electricity with biomass, you capture CO2 outside the power plant, and you liquefy it and you dump it under the ground. BECCS would become the biggest carbon sink, capturing 10 gigaton of CO2 after 2050. This is absolutely ludicrous, and it was denounced immediately. Because after the 2015 report, after the 2014 report, there was, of course, the 2015 Paris Agreement. And people started to be interested in the kind of science that was behind the Paris Agreement. And when they realized that it was this kind of very strange technologies, that created quite a stir. And if you NGOs, but also scientists complain about negative emissions. There was even a report written by a consortium of European academies of science saying that we cannot rely on these kind of non-existing technologies. This is dangerous to really depend on very fantastical technologies for the future of climate. And nevertheless, in the last IPCC Group III report, there is still a huge amount of negative emissions, slightly less than in the 2014, but still in 2022, you still, I mean, in all the scenarios, you need negative emissions, a significant amount of negative emissions to reach carbon neutrality. The negative emissions are treated in the 12th chapter of the IPCC Group III report. Interestingly enough, but I'm not saying that's the reason. The reason is much deeper. One of the leading author is from Saudi Aramco. But it is true that the story of negative emissions is quite interesting because I think it's not necessarily a kind of conspiracy. It's rather that you've got people who want government to be ambitious. So they push for a solution, which is negative emissions, but negative emissions rely on technologies which had been pushed by the fossil fuel interest for a long time, right? So it's really at the intersection of fossil fuel science about carbon capture and storage and computer modeling of net zero that this ludicrous idea of capturing dozens of gigatons of CO2 became possible. By the way, the world production of forests is just 4 billion cubic meters of wood per year. So if you want to capture 10 gigatons of CO2 with wood, you need to really expand a lot the production of wood. You need to triple for the forest production anyway. So that's what made the 2015 Paris Agreement possible. Basically, the idea that there was a technological solution out of fossil fuels, allowing the world to reach carbon neutrality between 2050 and 2070. But it relied on very, very dubious science. It relied on non-existing technologies. And I think it has played a very detrimental role in all the climate discussion. Because for 10 years, we have been talking a lot about technology, about even non-existing technologies. But we have talked a lot about innovation, about hydrogen recently. Hydrogen was very fashionable a few years ago in Europe. And we are not talking so much about redistribution, about sufficiency, about what is useful CO2 and what is useless CO2, what is luxury emissions and what are vital emissions. All sorts of discussion which should be far more important in our climate discussion and which have made quite invisible because of this very strong technophilia you find in the expertise. To summarize, I would say that it is quite natural that the IPCC Group III report are so technophile. Basically, you ask scientists and engineers to devise solutions. So, of course, they will produce papers on technological solutions, or they will want to show that they participate to the technological frontier because it is part of their mandate, you know. So in a way, one of the first problem of the IPCC Group III, it is its mandate to synthesize scientific literature. It is a very strange mandate. Most of the time, experts do not simply synthesize the whole literature. They give their opinion, they push recommendations over others. Here you've got something which seems very neutral, very like rigorous. You just synthesize the whole literature. But by doing this, actually, you synthesize a literature which is in itself very technophile, by nature, by construction, by the very the incentive that academics and researchers have, to be at the technological frontier. So there is a natural technophilia which should have been contained by the IPCC. But the big problem, and probably a kind of scandal, is that the Group 3 has certainly not contained the technophilia. On the contrary, it has fueled it. It has encouraged it. And the case of negative emission is probably a good example of this tendency. And really, I think, a very serious scientific mistake. And I think it is important for the IPCC to recognize this mistake, that they should not accept this kind of science to become, to get the official stamps of the IPCC. And I think it's very important to do that, because otherwise you just create a lot of confusion, and you create also a lot of hopes, and you shift the whole debate around technological solutions, and you tend to put in the background other discussions which are far more important. Thank you for your patience. I hope it was not too chaotic.
Thank you very much, Jean-Baptiste, for this very enlightening discussion, and also for helping us in the way, as you kind of call for in your book, starting this adult conversation that seemingly is very complicated in circles where we, would have assumed that this conversation is going to start to be predicated upon either science or, something else, but those and confusion or additions of confusion, I have to say. I'm myself very confused when I hear their work and when I read what they do. And your work in that sense has brought a lot of clarification for that. So as someone in my case who works on dam, I was just wondering, we'll talk maybe later, but where's water in all this as energy? Because it's actually something that you've kind of left out in your book. But I'm not going to touch that subject. That's not my point. Thanks again. It's very brilliant and enlightening. I would like to bring now Ashwini to the floor and, of course, let him discuss all this further. Thank you.
Thank you. Thank you, John Baptiste. Thank you for writing this paper, and thank you for agreeing to discuss this so well. And I'm also glad ERS has published this. This is very important, and the conversation probably some people it's obvious to some people, but it's not discussed well enough. So you well explained, so I'm not going into the details, but you said why IPCC has this certain specific approach, certain technophilia in promoting technology specific solutions. And you also, in the paper, you identify the limitations, the way IPCC authors are selected, or the process of writing those reports that naturally leads to that bias. But the key here is, how do we complement that discussion with other aspects, like the conversations on sufficiency, conversations on the redistribution, conversations on access. That's the key. How do we complement with that? And I have nothing much to add to the argument, and I totally agree with the argument, but I'll bring in some context to it. What is happening with this techno-specific approach when we try to solve climate change with technology only? So one of the technology you talked about is green hydrogen. And I'll bring in the Indian context here. So green hydrogen is being pushed in a big way in India, in several other developing countries right now. So I'm right now looking into 4 Asian countries: India, Laos, Vietnam, and Nepal. And all these countries, irrespective of their capacity and economy status, they are investing on green hydrogen. And it's happening because of 2 reasons. One, for the less industrializing countries, they probably see green hydrogen as an opportunity for first mover advantage. Because when you think about other clean technologies like solar and all, so already countries have captured the momentum and they have they're way ahead on the curve. So for these countries, developing countries, late industrializing countries, this is an opportunity to do industrialize faster. But what else is happening when you talk to stakeholders and look at the policy process? Why are you or at least setting goal to produce green hydrogen? So, to give you the context, India's current hydrogen consumption, not green hydrogen consumption is about 6 million tons per annum. Um, and it's projected to double by 2030, the consumption. And this is largely from fertilizer and petroleum industries, refineries and petrochemicals. And this will naturally double because of the growth in economy and demand. And India has set a target to produce 5 million metric ton of green hydrogen by 2030. That's like less than half of what India would need. But India is not aiming to produce it for domestic consumption. Forget about new demands like steel decarbonization. They're not even thinking of decarbonizing fertilizer and petrochemical. One of the biggest target is to export it to European market. And that's the same goal in all other Asian countries I talked about, Nepal, Laos, and Vietnam. And you're seeing a pattern of extractivism creeping into the clean energy technology as well, and the same colonial relations. So let's look at another clean energy technology, which is battery storage. So so first thing, the conversation in developing countries, solar plus storage could be the substitute for fossil energy like coal. And the prices are becoming competitive. Solar prices have come down, battery is getting cheaper day by day. But then the question is it accessible enough for everyone? If India has to decarbonize on the basis of solar and battery, does India have the raw material or the capacity to manufacture that amount of battery? Can India deploy that amount of battery? And think about the weather patterns, the environmental disruptions. You have to overbuild significantly if you rely only on technology-based approach. Um, so that's the other challenge. So again, within that, countries like India, which which doesn't have raw material for battery manufacturing, how do they deal with that? So now the solution is a circularity, another technology-based solution. So India, in fact, this year announced a program for not exactly a program, announced support for circularity, treating used batteries as a resource and for recycling them in India. So basically, if India pursues that approach, India will import used batteries from different countries and recycle them. And it has its own consequences, because when you recycle, you don't recycle 100%. You only recycle one part, the other part of the waste stays in the country. Which we are seeing in countries, other East Asian countries, with plastic recycling and all. This is sort of leading towards a so when we focus only on technology-based solution, don't look at the redistribution and other aspects. So this leads to a form of extractivism and reinstates the colonial relation of production and consumption here. So that's what I wanted to highlight. And then the second point I wanted to get into, you touched upon it briefly, the transition fallacy, which is like the clean energy transition has to happen much faster uh, to sort of decarbonize the economy or meeting the climate goals. So since I read your book last year, I mean, I'm supposed to be advocate of a clean energy. My job is to advocate, and I do that, and I still believe in clean energy. But the question is, how do we do that? So since I read your book, I now start questioning that. When we're talking about, let's say we'll do electric trucks, we'll sort of decarbonize the trucking industry. So if you look at, I mean, I don't know the global numbers, but if you look at India, about a quarter of oil consumed by trucks, medium and heavy duty trucks, not even the smaller trucks. So if you decarbonize that, there's a huge benefit, climate benefit. India saves money from export charges. So let's do that. But if we have to manufacture the batteries for the truck, if we have to manufacture the trucks now, then we'll probably increase the consumption of fossil. I mean, we have to do that with coal-fired electricity or coal-fired steel. So I don't know what's the pace where we can bypass that. This transition has to happen. So then the other side of the solution, which you talk about in the paper, which is downscaling certain consumption or degrowth, that's not politically attractive, and certainly not in developing countries. Certainly not in developing countries. You cannot, I mean, somebody who has never used a car, you cannot tell the person that, okay, using car is bad for the environment. You keep cycling or you keep working. So how do we manage that balance? The problem is understandable, but how do we manage that balance? How do we make downscaling of certain consumptions? I mean, you identify certain consumptions in the paper, you talked about it, but how do we make that politically attractive or um, I mean, there are some measures. I mean, India has a nudge-based approach with, I mean, if you have heard about the LIFE mission, so where the citizens are nudged to reduce their consumption, but that's not enough. I mean, we have to do it at a scale. So, uh, uh, yeah, I sort of wanted to go back to your argument in the book about the symbiotic relation. So, and my question is, how do we break that symbiotic relation between energy consumption as we move there ahead? And I'll stop there. And
Okay. So many different things. So if I remember, there is the problem of extractivism, colonial, the reputation of colonial relationships. Then there is the problem of how do you break the symbiotic relationship to get out of the transition fallacy. And third, the problem of degrowth in the poor world, basically. So regarding colonial relationship, yes, indeed. I mean, the green technologies are, for the most polluting part, are not being produced in the rich world. That is quite clear. Actually, France was a big producer of rare earths until the 1970s, 80s, and then it was shut down for pollution because it was too polluting, basically. And then China became such a leader in the production of magnets and so on that there is no chance of being competitive again. So I mean, Europe won't even try to really get a foot in this business. But on the other hand, for the case of China, the relationship has really inverted in terms of knowledge and know-how and patents. I mean, the case of battery production in France and Europe in general is quite clear. I mean, basically, we are begging Chinese entrepreneurs to set up a battery factory in northern France right now. And when it's not a Chinese company, we have to ask for Chinese experts to come to teach French engineers or European engineers in general how to produce batteries properly, because it is difficult. And the Chinese have 20 years advance in this domain, and it's very difficult to catch up without their expertise. And that's why I mean, the failure of Northvolt, European Swedish battery factory, which collapsed, and I think $1.5 billion of public subsidies went into smoke. I mean, it's a really big industrial failure. It's because they did not accept, from what I understand, they did not accept to follow the rules set up by the Chinese. So, in many ways, for Europe, it's quite a shock. I mean, it's not such a shock because Europe has been catching up with the US after World War II. So basically it's not such a shock, but there is this novelty that it's not from the West. So yes, I mean, in terms of materials, you're totally right. There are very strong kind of north-south inequities in the environmental burden of the green transition, especially with Europe. With the US, probably it's a bit different. US and Canada or Australia are huge extractivist countries. I mean, so it's a bit different for the case of the Americas. I was interested by what you said about the fact that India sees itself as a future recycler of used batteries, which is indeed very dangerous and concerning. I agree. For the case of export of H2, of hydrogen, I would be more cautious. I don't think India will export massive quantities of hydrogen because it is very difficult to transport. So it's very dubious. I mean, they could export probably like steel, green steel perhaps one day, but H2 is very difficult to transport, so it's quite dubious that it will be really a major commodity. For the how can you escape the symbiotic effect? Actually, you can't. I think it's important to recognize that it is the materiality. It's really linked with the how you make stuff. I mean, there is no like an easy solution out of the symbiotic effect. Electric trucks are better than gasoline or diesel trucks, obviously, but they are not carbon neutral, obviously. I mean, they're a big piece of steel and they will have an effect on climate and on the environment. And that's why we should not talk about electric truck like a green tech. It's less gray than diesel engine truck, but they are not clean tech. I think it's important to remain rigorous and not brandish these slogans. It doesn't mean that we should not try to electrify trucks, but we have to acknowledge that it is just a half solution, basically. Okay, I mean, it's just to force us to think about the numbers of trucks, the size of trucks. I mean, how can we reduce trucks? You could use train, you could use, there are also other technologies which are not clean tech either, but might be better than trucks. No, because that's really the biggest fallacy in the transition narrative is just we're going to electrify everything and that will solve the issue. That's really a lie. That's really a big lie. And electrification is old. We have been electrifying for a very long time, and CO2 emissions have not decreased. And there is the rebound effect, which is massive, because electricity is so efficient that we use far more stuff when it is electrified. And I mean, just imagine at electric motors versus steam powers. It's just amazing. The gain in efficiency is incredible, but then we have multiplied so much electric motors that CO2 emissions have increased since we use electricity for motors. So the same thing could happen with cars. I mean, there's just 1.5 billion cars in the world. If electrical cars are so efficient, and in the future they will be cheap because they are easier to build than gasoline engines, you could imagine 3 billion cars by 2050 or 2080. I don't know, but you could imagine a huge rebound effect on electric vehicles. And that's why it's very important to talk about prohibitions. I mean, we have to talk about that. Which lead me to your last question, which is, of course, the most difficult one, especially when I talk from Paris. I mean, degrowth is not politically attractive in France either. I mean, it's not. I'm not sure it has any more political supporter in France or in India. I'm not sure there is more in France. But I mean, basically, I don't see myself as. No, I'm just an historian. I'm not here to say we should do this or that. I think I mean, what is happening it happens way above us, 1,000 kilometers above us. It's a huge global thing which is happening in the world, this so-called energy transition or the climate catastrophe. And we just have to be rigorous about our description of the material world. And then, I mean, we'll see what the politician will do out of it, what the NGOs will do out of it, it's not our role to anticipate what we say, how it's going to be used, or it's not our role to imagine what is the right discourse to hope to change the things. I think we won't change anything, by the way. We are just obscure commentators on the material world, and we just need to be rigorous in our description. So indeed, if we don't talk about the limitation of consumption of certain things, I mean, we are not talking about major aspects of the problem. Basically, the only place where we can talk about transition is electricity, where you've got good technologies, or I mean, nearly clean tech, I would say, like 90% clean tech. But for all the rest, there is no energy transition. So I think it's important to really remain strict on that. Yeah.
Thank you, Jean-Baptiste. Thank you, Ashwini. Everyone, thank you for being here offline, online. We'll see you next year, next month for the next monthly seminar. Jean-Baptiste, thanks for being with us, and thanks. See you next time for some other discussion. Ashwini, similarly to you. Thanks a lot,
Ashwini, for the discussion.
Thank you.
Goodbye.
Bye-bye.